Hi guys. Today you're learning a little bit about the layers of the atmosphere, and I just want to show you your reference table. You're going to be doing some work with this tomorrow. I'm not going to push more work on you today, but I just want to go over a few things on your reference table. This is page 14 of your reference table. It's called the Selected Properties of Earth's Atmosphere, and I'm just going to quickly go through some things and maybe point out some more details about stuff tomorrow. So let's start on the left-hand side. As you can see, in the diagram, there is a chart of altitude, a scale of altitude, which is in miles and kilometers, as you can see right here. The scale in miles, each line goes by 5 miles, so 5, 10, 15, 20, 25. On the kilometer scale, it goes by 10, so 10, 20, 30, 40 kilometers. Now, as you climb into the atmosphere, as you go up in altitude, you're going to be climbing through 4 different layers. So at the surface, at 0, which is down here, we are living in this layer called the troposphere. Once you go up to the top of the troposphere, it's called the tropopause. That's where the troposphere ends. Think like pausing something. It's the end of it. And then you have the stratosphere, followed by the stratopause, the end of it. And then the mesosphere, and then the mesopause. And then finally, up top, we have the thermosphere. Now, outer space is generally agreed to start in the thermosphere right around 62 miles. So just around, right about here. Okay, this is 55, this is 60. It's right around this area here that outer space is agreed to begin. There are parts of the thermosphere which extend beyond that, but the astronauts, when they're up in the International Space Station, they're cruising in this area right in here in the thermosphere, just above um, the, well, pretty much in the middle of the thermosphere. Okay, so they're in this area here. All right. And we're going to talk about details of all of these layers and what they have and what's different about them. Tomorrow, we'll talk more detail, especially about the stratosphere and the mesosphere and the thermosphere. We'll talk about the troposphere today. All right, now, just to give you guys some perspective on scale here, Mount Everest, tallest mountain in the world, is 5.5 miles high, 8.8 kilometers high. So if you were to actually draw it on here, it would go up to just above this line right here. So we're talking in the troposphere completely. Mount Everest, the top of Mount Everest, is still in the troposphere. Okay. Airplanes, when you go up into a jetliner that's flying across the country, you're going to be flying up above the tropopause into this area called the stratosphere. Okay, and they fly just in the stratosphere, just up around this height, 30,000 feet or so, is right around here. Okay, just above the tropopause. The highest balloon jump, which you learned about Joe Kittinger back in 1960, that did this from a height of 14 miles or so. The highest, most recently, was Felix Baumgartner, and I'll show you a video of that. He jumped from 24 miles. That's right here. So he was in the stratosphere. And if you watch his video, it's pretty crazy. But if you watch his video, you can see how much of Earth you can see from that perspective. Okay, so 24 miles is the highest jump. Now, the astronauts, when they're up in outer space, they're flying or they're cruising around Earth at a pretty high velocity, right around 100 miles or so. Okay, so they're way up here in the thermosphere. So just to give you an idea of where they're at. All right, now a few things to note. The layers of the atmosphere are divided by temperature changes. Okay, and if you look at this scale right here, the troposphere, as you go up in altitude, the average temperature on Earth's surface is around 15 degrees Celsius. Okay, but as you go up in altitude, you know this, it gets colder and colder and colder and colder. Okay, until you get to the tropopause. At the tropopause, it swings back the other direction, and now in the stratosphere, it starts to warm up. Okay, and it's getting warmer and warmer and warmer and warmer, up to about 0 degrees Celsius at the stratopause. Then it flips back. Okay, now we're in the mesosphere, so it's getting colder and colder as you go up. And now you flip back the other direction and it gets warmer and warmer and warmer until you get to outer space, essentially. when there's no atmosphere whatsoever, and then it's basically there's no heat. Okay, there's nothing to trap that heat. There's no atmosphere. There's no molecules. Okay, it's a vacuum. So down here in the troposphere, it gets colder with altitude, and you know that because obviously, if you go up on the top of a mountain, it's colder than it is at the bottom. And by the way, it's about 3 degrees Fahrenheit for every 1,000 feet you climb, approximately. Okay, so if you're on a 1,000-foot mountain, it's about 3 degrees colder than at the sea level. Okay, um, at the other thing that I want to point out is as you go up in altitude, the pressure drops. If you go to the top of Mount Everest, the pressure is really low. It's about a third of what it is here on Earth. The on the surface, the pressure at the surface is 1 atmosphere, which makes sense. They call it 1 atmosphere because we have 1 atmosphere above us. Now, the other thing to point out here is water vapor. Water is concentrated primarily in this area down here below the tropopause in the troposphere. And that's a really big question. They're going to ask you about that. Where is all the water vapor found on Earth? And that is in the troposphere. It's right close to the surface. Why? Because the water comes from evaporation off the oceans down to the sea level and then goes into the atmosphere down here. And it stays concentrated down here. Okay, so that's a really big takeaway. Now, is there any water vapor above that? Yeah, a little tiny bit, but not very much. Okay, most of it's down here. And by the way, water is responsible for weather. So remember that. The weather is happening down here. This is where all the clouds are located. Water vapor makes clouds by condensation. Okay, so that's one big, huge takeaway from this. Now, another thing to point out is ozone. We'll talk about ozone maybe a little bit more in detail tomorrow. But ozone is located in this area called the stratosphere. Ozone is actually O3, oxygen 3, right? Normally it's O2. That's what we're breathing as a molecule. Two oxygens combined together make a molecule. O3 is made in the stratosphere, okay? And that's from UV radiation. We'll talk more details about that from later on. But at least you get the basics. And again, when Felix Baumgartner jumps from that balloon, he's jumping from the stratosphere, falling through the tropopause down to the troposphere.